Okay, more calculating of equilibrium stuff. They give us a reaction here where nitrogen reacts with hydrogen and forms ammonia, so we can write a reaction quotient for that. It's ammonia. Coefficient of 2 means it's squared over nitrogen. Coefficient of 1 means power of 1. And hydrogen, coefficient of 3 means power of 3. So there's our equilibrium law, or our reaction quotient. And now they give us all the numbers. They say we're at equilibrium and these are all our concentrations. Find the equilibrium constant. Well, our NH3 number is 1.230. Don't forget to square it. Nitrogen is 0.885, right there. That's an 8. First power. Hydrogen is 0.665. Third power. And now we mash a calculator, and 1.23 squared divided by 0.885 divided by 0.665 to the third equals, and I get 5.813022665. And if we're at equilibrium, then this number is called the equilibrium constant, and we usually call it KEQ. Final point about this, significant digits still matter in this unit, so I shouldn't give this whole decimal dump for the answer. We used 0.885, which has 3 sigdigs. This has 3 sigdigs. The ammonia number had 4, but we're restricted to the fewest number of significant digits. We can only give 3. We cut this off at 5.81, and 3 isn't big enough to round up. So 5.81 is the right place to stop. Equilibrium constants change with temperature. So often when we give one, or when we talk about an equilibrium, we'll specify what temperature it's at. For the moment, this number is fluff, and you can ignore it. Except you should know that if someone says at 350 degrees the equilibrium constant is blah, 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 and then they start talking about like 200 degrees, all that information is invalid because the K has changed now. So for the moment, you can mostly ignore this. I don't think we have any questions where we try to trick you by changing the temperature, but if we were in a really vile mood, I suppose we could. Just know that this, every K, like 5.81, is attached to a specific temperature, and if the temp changes, you can expect a different K to come up.